Welcome to Teacher Black Academy. Question 2, that's mechanics. We have box 23 kg, and then box A, and then box B, which is 31 kg, and then we have force applied is 134, and then the angle at 36 degrees, and then each box experiences friction of 45 newtons. That's the friction on the surface, so the friction there is 45 newtons. And we can go on and answer question 2.1. It says the free body diagram. So free body diagram, we have the weight there, and then we have the normal force, and we have force B on A. So the force that is being experienced between B and A as they come into contact, and that's according to Newton's third law. So force B on A. Alright, and then we have the friction that box A is experiencing, and then the force applied there at an angle going to the right. So at the angle going to the right, and that's the force applied, which is 134 newton. 5 marks of 1 2 3 4 5 forces. So always look at the marks and determine how many forces you have. So it's 5 forces actually. You should have 5 or more, but we just have 5 for the meantime. So for B, we have weight, friction, normal force that A applies on B, so force A on B, and then from there we can just resketch that on 2.2. So that's our object. So we have the normal force there, weight actually, so we have the normal force, and then we have the friction there, and then we have the force experienced between the force A on B. So that's the force that makes object B to move. And then Newton's second law determines that the rate of a rate of change of momentum. So the rate of change of momentum is Newton's second law, even though we know that it's the product of mass times acceleration and so forth. So Newton's second law, we should write it in an equation. Horizontal, all the forces horizontal, so we have 1 2 and 3 force applied, first and B friction, and the force applied. So the force, so that will mean that we have the sum of the force of A, that is horizontal. So the horizontal, we take X, so all the horizontal forces will mean that we have the bigger one, which is the force applied, and then it has it's minus, because the friction is negative side, it's minus friction, kinetic friction for object A, and minus the force that B applies on A. So the force that B applies on A, and all of that gives us mass times acceleration. So it's mass A times acceleration. Acceleration is the same, so you can't differentiate between acceleration A and B in terms of the boxes. So force applied is 134 newton at an angle of 36 degrees, so that's cos 36 degrees. So that's 134 cos 36 degrees minus friction, that's 45, friction there, that's 45 degrees on box A, that's 45 newtons actually. So 45 newtons for friction, so we have 45 newtons there, friction on box A, minus the force that B applies on A. Okay, so all of that gives us mass times acceleration. Our mass is 23 kg, and then that will mean we have 23A, so that gives us 23A. And state Newton's third law. Newton's third law states that it's an action reaction. So Newton's third law just says that if I punch you, I'm gonna punch you back. So it's like a revenge thing, a retribution. So you just get some kind of retribution, so that's what Newton's third law is, that nothing is for free. You hit me, I hit you back, you take from me, I take back from you, and so forth. So that's the action reaction. You hit the wall, your hand will be painful because the wall has hit you back. So it states that if body A exerts a force on body B, then body B exerts an equal. Okay, so it's an equal and opposite. Okay, so it's gonna be an equal and opposite reaction force. Okay, so it's equal action reaction force on body A. So A exerts a force on B, B exerts the force back on A. Calculate the force that box A exerts on box B actually exerts on A. So we see we have force applied, we have force B on A, and then friction. So that negative from both sides and positive. So what we have there, we have the force net there, which is force applied. Force A on B is going to be that's the force net. So all the forces combined, that force B on A. So force A on B is equals to force B on A, but on opposite direction. Okay, so force A on B is equal to force B on A, and with opposite sign or opposite direction. So force A on B is the remaining force, because remember, let's take direction east as positive. Okay, east going to the right, actually east or right as positive, and then we have force applied there minus friction, you know. So whatever is left, it will be the force that the object A can act on B, and that's the same object that B can act on A on the opposite direction. So force applied is 134 Newton, cos 36 degrees, minus our friction is 45 Newton. And then using a calculator, we find that cos 36 multiplied by 134 gives us 108, and then multiplied minus 45 is 63.41, near rounding off to the nearest two decimals, so 63.41 newtons. Now therefore force that B applies on A is going to be the same thing, but in opposite direction. So it's going to be the same thing, which is 63.41. okay, so which means if the A on B was east and then B on A is west. So traditional force due to surface, frictional force, actually traditional is the frictional force due to the surface will be the force that that opposes. So it'll be the force that opposes motion, the movement. And opposing movement is not a bad thing. Like in a car, for example, when the car gets into contact with the surface, which is the surface of the road, that resistance of the road is the one that makes the car to move. Remember, when it's in the mud with less resistance, it cannot move, you know. So the engine pulls the car on the other side, so the friction pulls the car on the other side. So force that opposes the motion of an object and which acts parallel to the surface. So it opposes direction and it's parallel, exactly parallel. And then box A and B made of identical material, yet each experience the same friction force, and we have to explain that. Same material means that coefficient constant, coefficient of kinetic energy is A over G, and remember that A acceleration is the same. So same because it's the same system. Remember, they're made of the same material and then they are combined. So what we have to do, we have that with one system, so which means the material is the same as we're told, and therefore the mass is combined and the normal force, so the static coefficient will give us the same value. So it has nothing to do with the weight of the material. Okay, so it's just the material type and then the different types of materials between the surface and the object on that surface. So static coefficient, coefficient of static friction multiplied by normal force, and the normal force there will be the combination of those two masses, 23 kg plus 31 multiplied by 9,8. So that's how I express it. So that's our final answer for 2.8. And if you have any question, please don't hesitate to leave below. And as always, I'd request you guys, if you don't mind, please subscribe or follow, and then you can also pass on this channel to others who might be of use to them when they need some help, especially maths, physics and chemistry. And this is your tutor, Black Adam. Don't forget to follow, subscribe. Thank you so much for watching.